When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
Welcome to one of the past HSC exam question videos. What we're going to do in this video is we're going to cover this exam question, which comes from the acidic environment module, more specifically the acidic oxides chapter. While doing a second, I'll read the actual question. Once I read the question, you get about 5 seconds to pause the video. Once I've paused the video, you can attempt the question, then press play when you're ready. And I'll go over the actual answer itself. So the question is, in 2004, Australia's Minister for the Environment announced that the allowable amounts of sulfur in unleaded petrol and diesel would be reduced over the next 5 years. Currently, sulfur dioxide in diesel is 500 parts per million ppm, but it will be cut to 50 parts per million on the 1st of January 2006 and capped at 10 parts per million from January 2009. There's two questions. Question A is calculate the volume of sulfur dioxide produced when a full tank capacity of 60 kilograms of diesel is consumed at 25 degrees Celsius and 100 kilopascal in November 2007. And that's worth 3 marks. And B, evaluate the effect of sulfur reduction policy on the environment. That's worth 4 marks. So when you're ready, pause the video and attempt the question, and then press play when you're ready. Welcome back. Alright, let's do A first. So for A, what do we have given? Well, it says calculate the volume. That's what we have to do. Obviously, we need to use 25 degrees Celsius and 100 kilopascal to do that soon. But first, we need to find out how many moles we have. And what does this actual question tell us? Well, it says we have a capacity of 60 kilograms of our fuel, and it says that we want to calculate it for November 2007. So then we would use, this is on January 2006, and it says that we have 50 parts per million, so 50 parts per million of sulfur in diesel. That's what it's telling us. So if we have 60 kilograms, so now what we have to do, if we know parts per million of sulfur in diesel, and we have 60 kilograms of diesel, and we need to figure out how much sulfur there is. That's the first step. Now how can we do that? Well, we know that, for example, 50 grams of sulfur are in 1 million grams. And the reason why I use grams here, I could have used any unit, but the reason why I use grams is because obviously we're going to deal with moles and we should have it in grams. But because 50 parts per million, we know that 50 grams is in 1 million grams. That's what we know just because of that statement here. But we don't have a million grams given, we've got 60 kilograms. So first thing we have to do, we have to convert those 60 kilograms into grams. So that's 60 times 1,000. So we actually have 60,000 given, which means we don't have all that million, we only have 60,000. 60,000. So we want to know X. I'll write it again. We want to know X. We know that in 50 grams, we've got 1 million. We know that 60,000 is what we actually have, but we want to have that X. So what do? We solve for X. So we bring 50 to the other side by timesing it by 50. So times 50. And then divide it by a million. So we've got X equals, I'm going to remove that, 50 times 60,000 divided by 1 million. Yes, you're going to write numbers of zeros, yeah. And that gives us 3. So X is 3. So now we've established there is 3 grams of sulfur. That's what we've done here. 3 grams of sulfur in our initial 60 kilogram tank. And then what we have to do next is we have to write the equation. So how do we make sulfur? Because it's asking us for not sulfur but sulfur dioxide. Right? But the equation for sulfur, you should have known this because this was something that was a dot point as well. Sulfur plus O2 goes into sulfur dioxide. That's the equation. Right? And what we have to do next is we have to actually calculate how many moles of sulfur we have. So we have 3 grams of sulfur. How do we get the moles? Well, the equation for moles was N equals small m, which is mass, divided by molar mass. So we know our mass is 3 grams. We need our molar mass, which is just sulfur. So we can look at the periodic table. In this case, I got it. So this is the atomic weight for sulfur, and it says it's 32.06. I'm just going to use 32 to simplify. So how much moles of sulfur we have, that would equal to 3 divided by 32, which equals 0.093 moles. So now we've got the moles, and because in this case there's 1 mole of oxygen, 1 mole of sulfur goes into 1 mole of sulfur dioxide, we know that 1 mole of this equals to 1 mole of this. So if we have 0.093 moles of sulfur, we also have 0.093 moles of sulfur dioxide. So we'll have 0.093 moles because of Avogadro's law of sulfur dioxide, because the amounts of moles are equal. What do we do next? Well, now because we need to get the actual volume, we can get the volume now because we have N, which is our number of moles. We want volume, and we have our molar volume. Because molar volume, if you look at the back of your booklet in your exams, you'll find out the molar volume will be 24.47. Actually, wait, sorry. 79 moles per liter. That's just in your book, so you don't have to memorize that. I just tried to memorize it, but you don't have to because it will be in the back of your book. And then you can put all those figures in. You got 0.03 for our moles. So N, that was 0.093 equals in our V, so it's what we want, our volume. And our molar volume is 24.79. So if we times both sides by 24.79, this will be gone, and we have it on the other side. So then we have 24.79 times 0.093, and that will equal our volume, which is, so that's right there, times 24.79. That's 2.32. So we have 2.32 liters of sulfur dioxide. That would be the answer for this question. So this is the actual answer. So calculate the volume of sulfur dioxide produced when a full tank of diesel is consumed at 25 degrees Celsius and 100 kilopascal. In November 2007, we would exhale 2.32 liters of carbon dioxide. Not carbon dioxide, but sulfur dioxide. At B, so for B, it was evaluate, again, you get marks for your actual writing, so you've gotten a mark for figuring out how to get the grams of sulfur, then to use the right equation to get moles, and then being able to use that moles to get our volume. So this would be 3 marks, 3 out of 3. So not just the actual result is important, but how you got there as well. Right, B, evaluate the effect of sulfur reduction policy on the environment. So what you should do for this is, for 4 marks, just talk about what sulfur does. So the sulfur, you can quickly say how it's produced, but more importantly is how or what effect it has. So what effect it has on the environment and on living things. And then say that if we have a reduction policy, that means we can minimize those effects. That's what I wrote. So my first point was sulfur can react with oxygen in the air to produce sulfur dioxide, and sulfur dioxide can react with water to form acetic acid or acidic rain. And this just to quickly went for the first point of how it was produced. So this was the first sulfur dioxide being produced. That was our first equation. Then we can go from sulfur dioxide to sulfur trioxide, and sulfur trioxide can come in contact with water, H2O, to form sulfuric acid. And this is obviously, the reason why that's important is because now we've established that sulfur can lead to sulfuric acid, and then we can talk about what sulfuric acid itself does in terms of the body and the environment. That's what I'll do now. So sulfuric acid can react with marble to damage ancient buildings. And then this is just the equation for that. H2 as sulfuric acid plus calcium carbonate, which is a solid, will turn into carbon dioxide, water, and calcium sulfate, which is aqueous. So that's why that solid was damaged, because now it's gone liquid or aqueous. That was first point. It can damage buildings. You should have also written that acid rain can also decrease the pH of lakes and rivers, killing living things and damaging plants by changing. So it can kill living things because it obviously can also affect, for example, the pH of rivers and lakes. It can damage plants, and it can do so by changing the soil pH. And if you remember, all soils, all plants have their specific pH they need to have to grow properly. So if you change the soil pH through acid rain, that means the actual plants can't grow as well anymore. And it can also damage the leaves, especially cuticle of leaves. So these are a couple of things that can happen if we have too much acid rain. And that gets you a mark as well, or actually you probably get 2 marks for all the things you mentioned here. And so sulfur dioxide in the atmosphere, this was all sulfuric acid, which we can get from sulfur dioxide. But now I'm also going to talk about sulfur dioxide itself. Sulfur dioxide in the atmosphere can cause respiratory problems in people, especially asthma sufferers. That's your main concern. It's got your respiratory problems as well. And then last was the concluding statement. That's actually a really important statement as well. So sulfur dioxide reduction policies can reduce the occurrence of the above mentioned consequences of sulfur dioxide pollution. Because the actual question says, evaluate the effect of sulfur reduction policies on the environment. If you just talk about what sulfur dioxide does, it's all good. I mean, that's what you should be doing. But you also have to just have that statement where it says, if we reduce the amount of sulfur dioxide in the atmosphere through these sulfur dioxide reduction policies, what that means is that we'll minimize all these problems as well. And so you get 1 mark for that statement, correct? Saying that, if we decrease sulfur dioxide, that means we also decrease these problems. And then obviously you get your other 3 marks for just mentioning all these problems that could come about when it comes to sulfur dioxide in the atmosphere. And that gets you your total of 4 out of 4. And where does these questions come from? Well, the first one comes from analyze information from secondary sources to summarize the industrial origins of sulfur dioxide and oxides of nitrogen and evaluate the reasons for concern about the release into the environment. So that was your 4-mark question, your B, that come from this one. The first one, the calculated volume, came from this one. Calculate volume of gases given masses of substances in reactions, and calculate mass of substances given gaseous volumes in reactions involving gases at 100 kilopascal or so at 0 degrees Celsius 100 kilopascal or 25 degrees Celsius and 100 kilopascal. In this case, we had a 25 degrees Celsius and 100 kilopascal question. I hope that was useful.
Thank you for watching.